This is the section 4.3 review, number 9. Calculators are allowed. I will do it without the calculator, but you're more than welcome to use the calculator just to verify things that you find. So if we look at number 9, it says, I want to find the maximum acceleration attained on the specified interval. So what that means is I want the highest y coordinate on the acceleration graph. And notice that I don't even give you the acceleration graph yet. So for each of these, you're going to have to figure out the acceleration first before you try to maximize. So on part A, we can write that the acceleration will be 3t squared plus 10. For part B, we can write that the acceleration will be 3t squared minus 26t plus 47. And on part C, we can write the acceleration will be negative 3t squared plus 6t plus 1. Okay, now, in order to maximize things, if we remember from section 4.1, you find the maximum locations by taking the derivative and analyzing the sign changes on that derivative curve. So we've got to find the critical values of the acceleration curve, which means we're going to need to look at the derivative of the acceleration. In this case, it's 6t. On part B, it will be a 6t minus 26. And on part C, it will be a negative 6t plus a 6. In order to find the critical values, we set those equal to 0 or undefined. Since these are all polynomials, there won't be any undefined. So we're looking only for when it equals 0. Well, this happens when t is 0. And here's my acceleration's derivative, so that's what I'm going to do the sign chart for. And notice here that my domain is only from 0 to 5. So 0 was my critical point, it was also my end point. So between that, say at 1, the output of my acceleration's derivative will be positive. That means my acceleration is climbing the entire time. Because my acceleration is climbing, I can see that the max is going to occur here when t is at 5. The goal is to find the maximum acceleration. So I'm not asking at what time the maximum acceleration occurs. I want to know what the acceleration actually is. That means I need to take the 5 and plug it into the acceleration curve. When I do that, I get a 3 times a 25 plus a 10, so I get a maximum acceleration of 85. If I do that same process on B, I can see that my only 0 is at 26 sixths, or I can do 13 thirds. Again, I can do a sign chart for A prime, because I'm looking for maxima and minima on A prime, or excuse me, on A. So my only critical value for A is 13 thirds, and I'm going between 0 and 4. Well, that's going to be below that 13 thirds, because that's 4 and a third. So the critical point is actually outside the interval. So again, I just need to test what happens between 0 and 4. If I plug in a 2, I'll get a 12 minus a 26 is a negative. That means my function is falling the whole time. So my max occurs up at this top end point. So the max is at time equals 0. I plug that 0 into the function, and I will get a 47. So 47 is the maximum value for this one. Part C, the final one, if I isolate t, I get t equals positive 1. So I do a sign chart for A prime. I've got a sign change at, or not a sign change, a critical value at 1, and my open interval, actually, my domain is going to straddle that, which is nice because I actually have an interior critical point. Prior to 1, say at a half, this will be a negative 3 plus a 6 is a positive. After that, I will get a, say a 2, that's a negative value. So my graph of A will rise and then it will fall. So we can see that the maximum is going to occur here at 1, and I'll need to plug that 1 into the function, and I will get a -3 plus a 6 plus a 1 gives me a 3 plus a 1, or a 4. Now, quick reminder, you need to make sure that you consider the endpoints on every one of these, because you're on a closed interval. Sorry, I scooted that up. If you're on a closed interval, your endpoints are always candidates. So just because you find a critical value does not mean it's going to be the location of the max. So make sure you test all your critical values and your endpoints. That's enough of a warning about what's coming.